Hello everyone, this is another tutorial. This is going to be a snake game tutorial, pretty basic. First I just want to quickly say that there are a couple ways to make this type of game. You can make it entirely UI based, user interface based, and that would be using these game objects, mainly images. That would be, your snake, your parts of your snake, your grid slots. So you can do that all UI based. You can also do it just using sprites, which would be these 2D objects. There's ups and downs to both of them. The UI objects you won't be able to use physics, but the sprite objects, overlaying is a little more difficult, and the camera position is the hardest part, because the camera for UI is always, or the UI is always overlaid in the center of the camera, whereas if you're using the world space coordinates, which is what you would be using for sprites, then you have to make sure the camera is centered on the sprites. So for this tutorial, I have used world space coordinates, so I'm centering the camera. And I'm actually just centering the camera at 0, 0, which works out nicely when I'm creating the grid. So I'll give you a quick demo of what it looks like. So I've got a grid. This grid resizes to any screen size. It doesn't do it at runtime, but it does do it like outside of runtime. So if I switch to Android, it'll create the number of grid slots for Android. It actually looks better on Android. But anyways, so you just use the arrow keys to move. It moves a certain, or it moves a square every second, or every, actually 0.7 seconds is when it moves. And every time it picks up one of these pick-upable objects, it increases the game scale speed. So this means it's increasing the speed of the snake, but it's also increasing the speed of anything else in the game. So that's called time scale. If you only want to target the snake for an increase in speed, then that's possible too. In my case, it made more sense to just target time scale, and I'll show you how to do that in a second, or in a bit. And also, if you collide with your body parts, you will lose the game. And for right now, just a very simple game over. When you lose, the game just restarts, and it has a little debug message that says game over. If you notice, the head of the snake is turning as I'm turning with the keys. The way I did this was actually just move the eyes and rotate the eyes based on which direction you're going. So the hexagon in the center, or the hexagon which is the snake head, it does not actually rotate. You can make it rotate. I just decided to move the eyes. If you make it rotate, it might deform a little bit depending on your resolution size, so this way works well with any resolution as long as the eyes are in the right position. Okay, so I'll show you what happens when I lose. Game restarts. It always starts in this stopped position, and that way the user gets the choice of what direction they want to move. And then also if you hit the sides, it's a game over. Okay, so pretty basic. Now I'll show you how I did it. So you can see here's the 2 game overs. So pretty much everything is the grid. The grid even controls the movement of the player. If you wanted to make a more in-depth player, you probably want the player's movement to also be separate from this grid controller. Since this is going to be pretty basic snake game, I didn't feel the need to do that. Okay, so let's look at the code for grid controller. Let's start at the top. I've commented this a lot, and I'll be sharing these 2 scripts with you so that you can go through and figure out how everything works. So let's start with these two private lists up here. So these are just all the slots for the entire grid. Each slot is basically going to be an index in this list, and the direction that the grid moves, starting at 0, is moving straight up, so in the y direction, until it hits the grid height, and then it moves one space. It goes back to the first slot, it moves one space to the right, and then it starts going up again. So if I were to show you real quick what that looks like here, just pause. This is the 0 grid slot. It goes up until it hits the grid height. So if we counted this out, we have a grid height of 16. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 0 through 15, which is 16 slots. And then it starts here again. This is 16, and then so on and so on. So it's up, upward, or in the y direction is the way the grid is done. Okay. So body parts. This is a list of all the body parts that the snake has. It starts out with one body part. This is a body part, and as you collect pieces, you add more body parts. So that's what this list is. It's just all the body parts. This does not include the snake head, since that's not a body part. Okay, so grid width and grid height, these are just default values. As you can see, I've changed what those values actually are. You want to set the grid width and height to be in direct relation to the resolution. So if this is 400 by 800, which means the width is half of the height, which is why it looks so square when I use 400 by 800. It's because I'm following that aspect ratio. So make sure that whatever size you do, you try to keep a consistent aspect ratio, and you'll get that square. If you don't want that square look, then you can obviously change this however you want, but that's how you would get a square look. So these are just default values. Those are changed. These are public, so they're changed in the editor. And then slot width and slot height. These values are how, they're what they sound like. They're how big the slot is. So just using grid width, grid height, all of this information, you should be able to create the slots, but then you also you're probably going to want to cut off a part of the entire slot so that you get the spacing in between. That's why you need that grid slot, or that slot width and slot height. Okay. So I created a body part as an object, so that's what this list is full of. It's full of these. These are body parts, and that's just the game object of the part and the slot number. And then this is just a constructor to create a body part. Okay. And then here's all the directions you can move: up, down, left, right. If you want to move diagonal, you can add that. It's going to add. You're going to have to add it in more places than just here, but this is where you would start. You can go through all of these comments later. Here's how I explain why I use the eyes instead of rotating the object. Okay, so here's all my prefabs. If we go back to Unity, so you see I have the slot prefab. I just used a white square. You can change this prefab, and all of the slots will change because it's basically creating this prefab a ton of times. The snake head prefab, here's the snake head. It's going to instantiate this as well onto a random location on the grid. We've got the snake body prefab. You can change this however you want, and every time a new snake body is created, it will look like whatever this is. And we've got the pickup prefab, and that's just the object you can pick up. Okay. We've got the two eyes. I always start off with the stopped direction so that the user can pick whatever direction they want to start with. This gives them a little time to decide. some snakes games you start off immediately going left or right or something. I just thought this was better. The current slot set to 0, that's just a placeholder value. Current slot is the slot of the head of the snake, the current slot of the head of the snake. So in the beginning, when the snake is set randomly, this current slot will be updated to whatever position the head of the snake is at. And you have to remember these slots are values from 0 to whatever the grid width times grid height value is. So 0 to, in this case, 8 times 16. And so you have to keep that in mind when you're thinking about slot numbers and what number is what number. Okay, and then old slot, I save the value of the slot that the snake was previously at because we need to move the body part connected to the head of the snake to the slot that the snake used to be in. Okay, and then I have I access the player here. Well, actually, the player is created here, so this actually gets set to the instantiated player. And then we have, this is a singleton object, and so it has a global or a public static instance of this object. And then start, if you've never seen this before, this is what you would do for singletons. You just check to see if this instance is already null or is null. If it is null, it means there hasn't been any other grid controllers yet, and so you should set this specific instance or the specific object to be the global version of the grid controller. So this is if there isn't one yet. If there already is a global instance of this grid controller, like say for example, I put in 2 grid controllers into this scene by accident. Whichever one runs this start first will be the instance, and the second one that I have will get destroyed because instance will not be null. So hopefully that makes sense. Whenever you're using random values, you want to make sure you change the seed or the init state. This is so that you don't get pseudo-random, you get real random. If you don't change the seed stays the same, and so every time you run the application, even though it's random the first time, the second time it's using the same random calculation that you used the first time, and so it's going to give you the same random, I say that with quotes, random slot value, even though it's not random because it's the exact same as the last time you used whatever random calculation. So this, setting it to datetime.now.ticks, which is basically milliseconds, it makes it almost entirely random. I mean, obviously, if you can start a game at the exact same millisecond as you have in the past, it won't be random, but chances are that's not going to be the case. Or at least you won't even notice because of how many, billions of milliseconds that at other points you will have started the game at a different location. So that's why you need to do this. The camera.main orthographic size, I'm basically setting that based on the grid width and grid height. Well, actually just the grid height. I'm setting this because I want this to work with all aspect ratios, and this orthographic size is how you create that aspect ratio of the camera. This helps center and fit every slot inside of the camera so that you don't have slots that are overflowing outside of the view. So that's what this is. This is to basically make the camera fit to the size of all of the slots. So if you have a ton of slots, the camera is basically going to zoom out in a way. In fact, we can show that real quick. If I change this to, let's just do 100 by 200. This is going to be really small. Okay, well, that actually, I think it's too big. Let's try a value a little smaller. Let's do 40 and 80. Yeah, there you go. So when you get to a certain height, it just doesn't matter anymore. But as you can see, it just basically zoomed out. And this is really, really, really small. But I don't think you can get above 100 with this setup. I'm not even sure 100 will work. Yeah, it does. Anyways, let's go back to a more reasonable value though. Okay, and we'll go back to the script. This slot height, so if you remember above, we talked about slot height a little bit. We can tell now what our slot height needs to be based on the orthographic size, which is camera.main.orthographic size is half of the height of the screen, which is why we're multiplying it by 2. That's the full height of the screen. And then we're dividing by the grid height, because that's how many slots we want. So this gives us the slot height we need. Later, we're going to reduce this slot height value just a little bit because we want that space in between slots. If we don't reduce it at all, then it's just going to look like a giant white screen because that spacing doesn't exist. Okay. And then something similar for slot width. You can look up these calculations. It's just something I found on Google. And then we just have our function that creates the entire grid. So let's go ahead and look at spawn grid. We'll come back to this. So here's spawn grid. So it takes in a width and height, which in our case is just the grid width and the grid height. And we basically loop through the width and the height, and we create these slots. Now, I'm gonna explain why I use this width divided by 2 negative and positive, and height divided by 2 negative and positive. But I think you should try to figure out why I did this yourself. I mean, you could probably read it actually, but try to figure out why I used width divided by 2 instead of just using x starting at 0 and going to width. So if you figured it out, great. If you didn't, that's fine. The reason why I did this is I want the camera centered at 0, 0, and I don't want to have to move the camera. So if I start at negative width divided by 2 and go to width divided by 2, I have the same number of slots, I have width amount of slots, except now the center slot is at 0, 0 rather than the center slot being at whatever half the width is. And this way I don't have to move the camera, which is exactly what I want. I don't want to have to move the camera. And then I do the same thing for the height. So that's why I'm using the negative width divided by 2 and the negative height divided by 2. Okay, so inside these for loops, the nested for loop, I just instantiate the slot. I will make sure to set the parent of the slot to the grid, and that's why it's transformed, because this is the grid. This script is attached to the grid, so this transform is the transform of the grid. And then now that I've set this slot to be a child of the grid, I can set its local position, and it will line up nicely with all the other objects. So it'll also look better in the hierarchy if it's a child. Okay, so here I'm doing what I said I was going to do earlier, or talked about earlier. I'm changing the width, the slot width and slot height to add that little extra space. That's what this is. The extra space is actually the 0.5f. This x portion is actually, sorry. I actually changed the slot width and height here. This portion is, let's see, how do I explain this? So each square is 1 by 1. 1 by 1 by 1, technically. Actually, 1 by 1 by, yeah, 1 by 1 by 1. So x is 1, y is 1, which is all you need to know about, because it's 2D. And so the center, the pivot point of each square, is at the center of the square. So if I didn't add this 0.5f, then actually, why don't I show you what happens if I don't add the 0.5f? Maybe that's just easier. So as you can see, we've got these squares going off screen because the size of the squares are 1, and if the center is at the pivot point, let's actually look at this in scene view. The center is at the pivot point. Here's the center. Now we've got 0.5 that's off screen, 0.5 that's on screen, right? Because it's going to start, the lowest left point is going to be at zeros, or it won't be at 0, 0. It'll be a negative width divided by 2. But if we don't move it up by 0.5 for every slot, then we have 0.5 off screen because it's a 1 by 1 square. So whatever you make the size of your slots, mine's just 1, which I suggest doing 1, it's easier, but whatever you make the size, you have to add half the size to the slot width and height. Actually, to the position, not to the slot width and height, to the position. And this is of every slot. And so by adding this position to every slot, you push up the entire grid. It's basically transforming the grid, but you move it up and to the left, or sorry, up and to the right by, in this case, 0.5f, which centers it. And so you're basically accounting for that pivot. If the pivot is in the bottom left already, you don't need to do this. But in our case, the pivot is at the center of these squares. Okay, so there's that. So we just set the slot's position to this position we just calculated. The z should be 0 just because it's 2D. We don't want this to be really far in the, or really close in the z direction, so that's fine. Here is where I adjust, or I add the gap, essentially. I take that width and I subtract, in this case, just 0.2f. This is just an arbitrary number. You can put whatever you want, but you just know that it's going to add more or less space depending on what number you pick. And then I just make sure to add the new slot I created to the list of slots. Okay, so that's how the grid is made. Then we spawn the player. So let's look at how we spawn the player. So here's the player. So first I'm going to get the slot location that we want the player to spawn in, and I just have a function that does that. It's called getRandomSlot. Let's look at that real quick. These are kind of helper functions, so they're at the bottom. So getRandomSlot. It's a one-liner function. It just returns a random number between the grid width plus 1, the grid width minus 1 times grid height minus 1. So grid width plus 1, the reason why I chose this number is I don't want the player to start at the very edge of the screen. Because they could run into a wall immediately or lose the game immediately. So this starting value just puts them further in. You can just set this to 0, and it still shouldn't cause an issue. It's just now you might have a player spawn in the corner, for example. But you can set that to 0, and then you can also set this to. This actually does need to be grid width minus 1 times grid height minus 1 because it's 0 based. If we just did grid width times grid height, technically it would be 1 over. So another way you could actually do this is grid width times grid height, and then subtract 1 from all of this, and you don't need these extra parentheses. So we subtract 1 at the end because it's 0-based indexing, and this should not produce any values outside of the range of slots. So we just find a random value between these two. I actually like this better now, so I think I'm going to leave it like this, because the other was leaving out maybe more values than we needed to. So, okay, so here's the random slot. So let's go back. Okay, spawn player. So we've got this random value. We're going to instantiate the head of the snake. We're going to set the snake to be a child of one slot. And this is actually how we're moving the snake, by the way, is we're moving all the body parts, is we make the object a child of the slot, and then we just set its local position to 0, which puts it in the center of the slot, of whatever slot it is. So here we're just picking a random slot from our slots list, and we're making sure the snake head is a child of it, and then we just set the position of the snake to be 0, and this just puts it in the center of the slot. And then we update our current slot so that we know where the head of the snake is. Okay, pretty simple. What's next? Next we spawn the pickup. So here's spawn pickup. Again, we're just picking a random slot. We're instantiating. In fact, it's almost exactly the same as spawn player, except without that updating current slot. Okay. And add body part. Okay, here's add body part. This is a little more complex. We create a body part. We instantiate a body part. We also want to create a body part object. Remember, this is that class we created right here. And this attached body part is going to be the body part that each of these game objects is going to be attached to. It's what it sounds like. And this will be the new body part object that we're creating. So this is the new one we're going to need to save. So here we're checking to see if there are at least one or more body parts. And we're checking this because if there are no body parts, then the body part we're about to add is should be attached to the head of the snake. Every other body part after that one just needs to be attached to the last body part in the list. So this is for every other body part except for the one attached to the snake head, and this is for the body part that's attached to the snake head. So let's first go through the more common case, which is every other body part. So all we do is we're setting this attached object to be equal to the body part. So we have a list of body parts that we've already stored. We're setting this to the body part that's in the list that is the last body part in the list. That's why we're taking the count and we're subtracting 1, because it's zero-based indexing. So we're just getting the index of the last body part in the body parts list, and that's what we want to attach it to, because it always goes on the end of the snake. So that's all we want. And then here in this else, this is specifically for the body part attached to the head of the snake. We're going to create just some temporary objects so we can store the current slot value, and then we also want to make sure this is untagged so that when the player starts the game, this first body part starts on top of the player. That's just how it's spawned. If you want, you can do some more effort to make sure this doesn't spawn on top, but right next to, in whatever direction there is on the wall of the player. So for example, if the player spawns in the bottom left corner of the screen. So why don't I just show that a little bit. Okay, so let's zoom out. If the player were to spawn in this bottom left corner and you wanted to spawn this first body part to somewhere near the snake, you would have to check how close the player is to a wall, and then you would have to spawn the body part make sure that you spawn it in only spaces that are actually viable. You can do this. I didn't think that this was really worth it. I thought it would just be better in our case to allow this body part to spawn right on top of the snake, and every other body part spawns on top of the previous body part. That's just how I set it up. You can set it up differently. And so in our case, in the way I'm doing it, I need to set it to untagged because otherwise it will collide with the player, because the player checks for a tag for collisions, and then the game will be over instantly. And we obviously don't want to do that. So that's why I'm making sure just specifically this body part is untagged. Okay. So now, either way, based on whatever of these we chose, we're just going to create this new body part. We're going to set the parent of this body part to the grid, and we're going to add this body part to the list. And then we're going to quickly move all of the body parts. This just updates the position so that the new body part isn't just sitting on top of another body part, basically. It just updates all the positions when you add a new body part. And then here you can see I changed the time scale. This is what I was talking about earlier. This is how I speed up the snake every time you pick up or add a body part. This is how I speed up the snake. And basically I'm just time scale starts at 1, so I'm starting at 1, and then I'm adding the total number of body parts count minus 1, and then I'm just going to divide by 10 because the value is a little high. So 10 is just a number I liked. And so this means the time scale will scale based on the number of body parts. It'll increase slowly based on the number of body parts. Okay, let's keep going. And then here is the function that's called every 0.7 seconds. So I'm using an invoke repeating command. This is just, you give it the method, so move player is the method. It's a function that I've created. I'll show you in a second. This is how many seconds you want to wait before you start this command, so I'm just waiting 1 second. And then it's a repeating function, so how many times do you want to, or how much time do you want to wait in between each call, which is 0.7 seconds. And when you change the time scale, you're technically not changing this 0.7f, but this function is getting called more often because you're speeding up the scale of time. One scale of 1 for time scale means 1 second. Every second something happens. If you increase the time scale, now you have the time scale treating time differently. So instead of every second in game is a second, it might be every second in real life is half a second in game, or is 1.5 seconds in game, depending on which way you change the time scale. So that's how it works. Okay, let's go through update real quick. Here's where I'm just checking each key press, and I'm changing the direction accordingly. You notice there's no option to stop. That's because Snake, there is no key press to change the direction to stop. Once you start moving, you can't stop moving until you lose. Game over. We talked about spawn grid, we talked about add body part, we talked about spawn player, spawn pickup. Let's talk about move body part. So every frame we're moving the player, and we're also moving all the body parts. In fact, actually we should start with the player since that moves first. Did I pass it? Here it is, move player. So first thing we do is set the old slot to the current slot, because we're going to be changing the current slot, and so we want to make sure that we store whatever value was in current slot. So we're going to use a switch statement based on the direction, If it's stopped, we don't need to do anything for move player. It doesn't move when it's stopped, so we just return immediately. The rest of these are very similar, up, down, left, right. Just a couple values need to be considered. So first we do this check loss. That's to see if you're moving up and you're about to hit the top, then you should lose. You don't even need to calculate any of this where the player should go. You don't need to calculate it based on if they should be dead. So here's where check loss happens. So we'll go through it a little bit. So it needs a direction, and we do another switch on the direction. Once again, if they're stopped, they can't lose because they're not moving, so we would just return. And we return false because check loss returns whether they lost or not. It's true if they lost, it's false if they didn't. Okay, so if they're moving left and the slot that they're currently in is less than grid height -1, basically, let me show you this. This entire column is less than grid height -1 because grid height -1, or sorry, less than or equal to grid height -1, because grid height, remember, in this case is 16, right? This is 16. So grid height -1 is this value. So it should be less than or equal to, if anything less than or equal to this is this column. Anything less than or equal to 16. And so using that value, we know that if they're trying to move left and they're in this column, they should lose. And then the rest are basically the same thing, done a little differently. But for down, we're using a modulus, or modulo. Basically, we're looking for a remainder. We take the current slot divided by grid height, and we look for what the remainder is. If the remainder is 0, then it means that they are currently in this row, because this is for down. So if they're currently in this row and they're trying to move down still, they should lose. The others are very similar. I'm not going to go through them. You can try to figure out the math on your own if you want. But yeah, so that's how we check if they lost. So when we're moving the player, if they didn't lose, so if this didn't happen, then I have these functions to get the new slot. So 1 up, 1 down, 1 left, 1 right. Those are also, let's see, where are they? Right here. So 1 left, again, more calculations of what 1 left looks like. You can look through these and try to figure out how they work. You can change them and see what happens. But this is 1 left, 1 right, 1 up, 1 down. Okay. And now we're going to set the player slot. So this is basically updating the player's position. It's the new slot. And we're also going to update the eye position and rotate. This is how we make the eyes face the direction that the player is moving. So if we go to, I think it's also a helper function, yeah. Update eye position and rotation. 1 is for the first eye, so X loc 1 and X and Y loc 1. That's the X location and Y location for the first eye. And these locations are in local position. So the eyes are children of the hexagon, which is like the snake head. And so if we can adjust the local position of the eyes, and it doesn't matter where the head is in world space, the eyes will always position correctly based on the local space of the head. So and then we need something similar for the second eye, I2, and then we just have Z1 and Z2 are the rotations. This is the rotation of the eyes. The rotation is actually always the same, but it's still nice to keep these as variables in case for some reason we want the eyes to be cross-eyed or we want them to be facing in an opposite direction, something like that. This would allow us to do that. Okay. And then the direction is just whatever direction they're moving. We need this direction so that we can determine, or I'll show you. Let's see, where do I call this? Here we go. So, actually, here. No, not here. Here. Sorry. Here. So we have these eye position values. I only have the up. So when the eyes are facing in the up direction, I only have the position of the left eye when the snake head is facing up and when the snake head is facing left. That's what these two values are. This is the vector 2 position of the left eye when the snake is looking up, and this is the vector 2 position of the left eye when the snake is looking left. And those are the only two values I need to calculate the rest of the values, because it's in local space and the center of the hexagon is 0, 0. We can just use the negative of these values to get the position of I2 of the right eye and the position of each rotation based on, well, with up rotation we can get the down using negative values, and with the left rotation we can get the right position of the eyes using negative values. And so that's basically why there's a bunch of positive ones and negative ones. These are just adjusting those initial two eye position values so that we can position the eyes where we want them. Okay. So based on the direction, if the direction is less than 3, this means it has to be 1 or 2. 0 is obviously stopped, so it has to be 1 or 2. 1 and 2, if we look at what those directions are, there, let's go back up to the top. 1 is up and 2 is down. So basically this index is to help us understand, or to help us know which eye position we should be using. So there's two eye position vector 2 values inside that array of vector 2's. One is for up and one is for left. If we're trying to calculate the position in the down direction, we should use the up one because those are opposites. If we're trying to calculate the position of the right, the position where the eye should be on the right, we should use the left one because, again, they're opposites. So that's why we have this index here. It's to check if the current direction is 1 or 2 or 3 and 4. Okay, and that's kind of confusing. Maybe take a little while to figure out how this works. So then what we do is we just take the initial eye position and we multiply it by either 1 or -1 in the x direction. Same with the y direction. We set the local position of the first eye, and then we do the same thing for the second eye. I know this looks kind of daunting. It's really not. Just try to mess with the values and you'll see how it works. And then this last part is how we set the rotation of the eyes. Z1 and Z2 are the rotations, and if we go back to here, you'll see that in the up direction, that's the way the head starts in. It's 0, 0, because that's the normal rotation. If we're going down, we just do entire 180 so that the eyes are facing the opposite direction. 90 is left, and -90 is right. You could also do 270. This does the same values. negative 90 and 270 are the same thing. Okay, and then if they did lose in each of these cases, then the game should be over. So if we look at game over, it's just going to debug and load a new scene. Here's where you would add more stuff if you want for game over. And then after we've moved the player's head successfully, then we move the body parts. Okay, let's see. Where's move body parts? Here's move body parts. So the head is already moved, so we can't use the current slot number of the head to move the body, the first body part. So instead, we use the old. What is it? The old position? Yeah, old slot here, and that's why we have this check. Okay, once again, this if statement is to check if we're looking at the first body part in the list. If we are looking at the first body part in the list, then it needs to be attached to the snake, to the snake head. And so that's what we do here. This quick check here, if old slot is greater than 0, remember how we defaulted it to 0? The old slot should actually... Okay, wait. Sorry, that actually shouldn't be 0, because the old slot could be 0. It might cause a problem. It should be the old slot is greater than -1. There we go. Okay, so if the old slot is greater than -1, it means it's not set it to its default -1 value. And that means that we should actually do something with this knowledge. Otherwise, if it's still set to -1, then we know the snake hasn't moved yet, and therefore we can just move the body part to the position of the snake head. That's what this is doing. This is why this first body part is right under the snake until you move. That's how this works. Okay. So in the other case, where it's not the first body part, it's just some body part in the list of body parts, then we just set the slot number to the slot number of the body part that's one ahead of this object in the list. So basically we're just setting each part to the part in front of it, the position. We're setting each part's position to the part in front of its position. And we're actually, if you notice, we're actually going in reverse when we do this. We're not going forward. So we're not starting at I equals 0. We're starting at I equals body count parts.count -1. You should really try to figure out why I do it this way. So if you want, you can pause the video here and try to figure it out. So the reason I do it this way is if you're looking at the object ahead of you, or sorry, if you're starting at 0 and you're changing the 0 object before you change the first index object. Now when you get to the first index object, you don't know where the 0 object was because it's changed position. So you could store the old position of the 0 index object, or you could just start at the back of the snake, so start at the body parts count -1, and you can change the last object first, because we don't care about where the last object has been. We only care about where every object after has been. And so you can set the last object equal to the second to last object, and then you can set the second to last object equal to third to last without ever having to store a variable about the position of the previous object. So it's more efficient. You don't have to have a storage variable. That's why we do it backwards. Okay. Let's see, so what else? once again, we just set the body part to be a child of the slot, and then we set the local position to 0. Okay. Honestly, that's pretty much it. I know that was a lot to take in, and I might not have done a great job explaining it. That's what all these comments are for. They're to help you understand it a little better on your own. There are a couple things I suggest you try to do to see if you really understood this. Try to figure out a way to teleport or to create portals to teleport the head, and then have it so when each body part goes through the teleporter, it ends up a part of the snake head on the other end, if that makes sense. So I'll try to give a quick example. Let's say I have a teleporter object right here, and let's say I have like 4 or 5 body parts. When the snake goes through this teleporter object, let's say it ends up over here, and then say I move down 1. Now the next body part should also go through the teleporter and end up here. I move down 1 more, the next body part goes through the teleporter. So try to figure out how you can set that up based on the functions that are already given, especially the set player slot function. And then also, it's good practice to create UI as well, so you might want to try to create some game over screen, restart screen, a main menu, stuff like that. That'd be a good future understanding check. That'd be something you would use from previous videos, whereas this portal thing you can actually do with what's already included, except you might need some art, but you should be able to do this with what's included in this project. I'm going to quickly explain how the collisions work. So the player has a script, and the player, the snake head, has a collider and a rigid body. The body parts have a collider, and the pickup object has a collider. And so here, on trigger enter 2D, that's just that's the standard function for collisions, especially 2D collisions, or in this case triggers. Triggers and collisions are very different. I'll explain that real quick. A trigger means that if you have one object that collides with a trigger, they will not push against each other. Physics will not apply. Rather, it'll just trigger this function. That's all that's happening. So when the player hits the snake body, I don't want it to try to push against the body. I just want it to trigger this function. So that's why they're triggers and not non-triggers. And the way you set triggers is just right here. You just check or uncheck this box. Okay. So if they collide or trigger the pickup object, I'm going to destroy the pickup object. I'm going to, using that instance, that singleton I created, I'm going to add a new body part, and I'm going to spawn a new pickup. This is just so the game is, goes on forever. If the collision is body, we just want to end the game. And those are the only 2 types of collisions in the game. The other one is when you try to go to a slot outside the screen, but that's technically not a collision. It's trying to go to a spot that doesn't exist, and so that is also a game over. Okay, that is how I made the snake game. That's pretty much it. This is a very long video, so it'll probably be split up into parts. Let me know if you have any questions. Hopefully this helped, and thanks for watching.